चैनल को लाइक करें और सब्सक्राइब करें ताकि आपको सभी इंपॉर्टेंट अपडेट्स टाइमली मिल सके. Subscribe the channel now. Okay. So welcome all. We will be starting a new lesson today. That is chapter number 16, Light, from class 8th. This comes under physics, and this is a very interesting topic. In this particular topic, that is light, we will be studying about mirrors, like particularly plane mirrors, like the mirrors which are available at your home. So the same kind of mirrors we are going to study. After that, we are going to study a great deal about reflection. What exactly is reflection? What are its types? What are its features? Some laws regarding that. We will also have a certain introductory part of what is exactly called as refraction. So refraction is given in a very shorter way in, let's say, for class 8. This is the details about refraction will be taught to you in your 10th standard, but refraction is very much in shorter, it's given in a very shorter way in class 8. Also, we'll be seeing some phenomena, like for example, how rainbows are created, the phenomena related to light. That is also a very shorter kind of portion what we have, phenomena related to light. But a major portion is given for human eye. A major portion has been given for human eye and basically reflection. So this lesson, that is light, major portion of, so let's say, this lesson is covered by whom? Reflection, and another one is human eye. So today we will try to complete mirrors and reflection, and in the next let's say part, we'll be talking about refraction, phenomena related to light, and human eye. So let us begin. So our first point we are trying to talk about is reflection. Now reflection is not something which needs to be taught, because you have observed it so many times. You can see even in this picture, there is a mountain, there are trees, and those same things we are able to see in the water. So these things are nothing but which exist in the water. These are called as, this is basically image of, this is the object, right? So this is the object, this mountain, and this is the image which you are seeing right now. So this is image, and this phenomenon is nothing but called as reflection. This phenomenon is called as reflection. So this is the reflection of the mountain which we are able to see in the water. So you must have observed yourself also. You must have seen your face in the water. You must have observed your body in the water, and you must have seen the images, and that is called exactly reflection. But in this particular lesson, we want to know what exactly is the meaning of reflection and what does it really. So let's say, how do we see the objects, and those details we want to know. So let us just consider that there is a particular boy. Okay, this particular boy is, so let's say, how he is able to see the books which are kept in the room. So these are the books which are kept in the room. These are the books. This is a light source, like the bulb which is available in the room. This is light source, the bulb, light source. Light source means what? The object which is, so let's say, giving light, that is nothing but the light source. Okay. Now let us talk about how rays of light pass from the books and towards the person, and how that boy is able to see this particular books, the set of books. So let us just see. So what happens is that the rays of light will be coming from the bulb. The rays of light will be coming from the bulb, and after, suppose let's say, they fall on the particular book. Okay, they fall on the particular book, and then they get bounced back in the medium, in the same medium, and they reach the eyes of the particular boy. The rays of light, they enter inside the eyes of the boy, and then we are able to see that particular book. So the boy is able to see the books only because the rays of light, they came from to the books, and the same rays were bounced back in the same medium, and they entered in the eyes of the boy, and only then we are able to see the object. So in shorter way, we can just write down here that the rays of light should fall on the object. The object should, suppose let's say, somehow bounce back the rays. That means it should reflect, basically. It should reflect the rays, and the rays should enter the eyes, and only then we are able to see the object enter the eyes. So can we say that major portion, suppose let's say, whatever we see around us, like we are able to see like books, we are able to see our room, like computers and all. So major portion what you see around in your surrounding, that is because of reflection. So one thing you have to understand, that majority of the things which you see around you is due to reflection itself. So that's why the importance of reflection is enormous. Now let us first understand, we have understood that there is due to reflection we are able to see the world. But we also want to know what is the definition, because we should have a standard definition of this. So what is the definition? Bouncing back of the light after striking a surface. After striking a surface, or also you can say after hitting a surface. So bouncing back of the light after striking a surface is known as reflection of light. So that's a very proper, simple definition what you have there. Bouncing back of the light after striking a surface is known as reflection of light. So what should happen is basically the light should bounce back. It should bounce back, and only then you are going to say it's reflection of light after striking a surface. Now the second point which is very important regarding reflection is that reflection should happen in the same medium. Okay, reflection should happen in the same medium. Now what is the meaning of medium? Basically, medium is nothing but the substance. Medium is nothing but the substance through which the light is traveling. The substance through which light is traveling, through which light is traveling. Now what can be the examples of, suppose let's say medium? Medium can be anything. Suppose let's say air can be a medium through which light can travel. Light can travel through air. Light can also travel through water. So water can also be the one of the mediums. Light can travel even through the glass. So you can just say even glass is one of the mediums. Right? So there are different mediums like air, water and glass. But you have to understand that for reflection to work, the ray of light, like the incoming light and the outgoing light. For example, instead of writing down this one, suppose if I erase, fall and reflect, for example, and if I write down there, this is incoming ray and this is outgoing ray, for example. If we are giving it different names, outgoing ray. So you have to understand one thing, that the incoming ray and outgoing ray should be in the same medium. That means incoming ray, if it is present in air, incoming ray, if it is passing through air, then the outgoing ray should also be passing through the air itself. Only then you can call it reflection. For example, if the incoming ray is traveling through air and the outgoing ray is traveling through water, for example, if it is traveling through water after let's say bouncing, then it cannot be called as reflection. For reflection to work, you should have the same medium. For example, the incoming ray is water, it is passing through water, then the outgoing ray should also pass through water itself. If the incoming ray is passing through the glass, then it should pass, so let's say outgoing ray should also pass through glass itself. So that's a very simple logic, that reflection happens in the same medium. So that means your medium should not change. The incoming and the outgoing ray should belong to the same medium. Now let us talk about what are the possibilities after a light strikes an opaque object. For opaque object, not subject, opaque object. For example, suppose let's say there is some object. Opaque object means what? Through which light cannot pass, right? Okay. Opaque object means what? A substance through which light cannot pass. Substance through which light cannot pass. What can be the perfect example for this? Example, stone. Example, stone you can take, right? Or any solid object you can take. Even your Rubik's cube will give the same thing. Even your notebook, textbook, that is also the same thing. That is opaque object. Light cannot travel through it, right? Something like glass. So you can take any, literally any example which you have in your surrounding. So suppose let us say you take a book. For example, if you have a book, like this is your book. Now you tell me, like after suppose let us say some ray is, suppose let's say incident on this, there is incoming ray. Now there are three options what the material can do. Our current material is a book, and what kind of options there are available is, first thing, it can either pass through the object. The first is it can either pass through the object, but in our case it is not possible because we have taken opaque object. So the rays are definitely not going to pass through the object, but that is one of the scenarios. That is one of the scenarios, because if we take some, suppose let's say transparent object, like instead of opaque object, if you are taking transparent object, then definitely the rays will pass through it. So this is one of the exceptions what you have. So as we have taken opaque object, the rays of light are not going to pass through the object itself. So this is something which is not possible in this case. Absorbed by the object. Okay, yes, that is possible because rays of light can be absorbed also. All the rays, instead of going in the atmosphere or even inside it, instead of that, book is deciding to absorb all the light. Okay, light is basically energy, and book is deciding to absorb all the light which is incoming. So that is also one of the possible scenarios, right? And reflected by the object in the same medium. So this is also possible that the object is neither passing it, letting the light pass, or it is neither absorbing the light. Instead of that, it is reflecting the light. That is the third option we are looking for in the same medium. So after striking, if the ray of light goes in the same bag, it bounces back in the same medium, then it is called as a reflection. So that can happen, that you already know. So there are three possibilities: either the object is going to let that light ray pass, or it is going to absorb the light, or it is going to let, suppose let's say the third option is it's going to let the light ray reflect, that is bounce back in the same medium. So we have seen three possibilities of the rays of light when it falls on an object. Now let us talk about reflection has rules. Okay. So does this reflection has some rules? Like are there certain scientific rules regarding this? So yes, there are. Reflection has certain rules. Whenever reflection occurs, it follows certain rules. And what are these rules called as? These rules are called as laws of reflection. So this is the most important point which you have in your textbook. So you have to remember this. These reflection, whatever we have seen right now, this book reflection, or even, so let's say this opaque object reflection, or even this reflection which we have seen, and even this one, the mountain reflection, all these reflections are governed by, or they follow a certain rule. They follow certain rules, and those are called as laws of reflection. You have to understand, those are called as laws of reflection. Now there are two laws regarding this. There are two laws in laws of reflection: first law and second law. Let us try to understand. So what are the laws basically? Laws are nothing but the rules which are followed by basically reflection. So basically rules of reflection, but basically what we say is laws of reflection. So incident ray, normal, and the reflected, they lie in the same plane. Okay, but we are not going to understand these terms before we see the diagram. So what we'll do is, first we'll see the diagram, and again we will come for our laws of reflection. So you just focus on this. So what we have done is, we have taken a plane mirror at the bottom. So this is our plane mirror. Now what is the meaning of plane mirror? Plane mirror means the mirror which are available at your home. Those are called as plane mirror. So whatever the mirrors are available at your home, those are basically called as plane mirror. So this is a plane mirror, the mirror available at your home. Fine. Okay, home mirrors basically. Okay, so if you are having that mirror and if you keep it, and there is one incident ray. Incident ray means what? Incoming light ray. This is incoming light ray. So basically this is incoming light ray. Right? After, suppose let's say hitting that plane mirror is very highly polished. Mirrors are always polished, right? So the ray of light is again going to bounce back in the same medium. This bouncing back of the ray, this ray is called as a reflected ray. This ray is called as reflected ray, or we can also just say in simple terms it is outgoing ray. Okay, so there are 2 points basically. One is incoming ray, one is outgoing ray. Incoming ray means incident ray, and outgoing ray means reflected ray. So these are the 2 points. Now we need to find out the angles between the two. So what we do is, we basically take a line wherever the incident ray is incident. For example, it is incident on this point. So what we do is, we take 90-degree angle from that particular line. Okay, wherever this is called as point of incidence. This is called as point of incidence. From the same point of incidence, what we draw is, we draw a perpendicular, which is also called as normal. So this is drawn at 90-degree to the surface, that is mirror, and this is called as what? Exactly, it is called as normal. So you have to understand, this is called as normal, and that is drawn at 90-degree to the surface. So once we have drawn that, another thing which we want to know is the angle between incident ray and the normal is called as angle of incidence. So this angle, let us just say this is the angle, this is angle 1. What we can say, suppose let's say this is x. So this x is nothing but the angle of incidence, angle between the incident ray and the normal. Are you understanding this? This is generally measured in degrees. And let us just say the angle between normal and the reflected ray, it is y degree. Right? So angle of incidence is nothing but the angle between incident ray and normal. And what is angle of reflection? Angle of reflection is nothing but the angle between reflected ray and normal. And this is called as, suppose let's say y degree. In this case, you have to understand that x degree is equals to y degree. That is our one of the laws. This is second law. This is second law we are going to look into. So x degree is equal to y degree. So basically angle of incidence is equal to angle of reflection. And how we are going to write it, like in for representation purpose. So angle of incidence is represented by angle I generally. It is represented by angle I. And angle of reflection is generally represented by angle R. Angle R. So according to our information, if you measure these two angles, both of them will be equal. If you measure these two angles, you will be able to see that angle I is equals to angle R. Angle of incidence is equal to angle of reflection. That is our second law. So you can just see here, the second law states angle of incidence is equal to the angle of reflection. So that is what we have seen right now. The first point, let us try to understand now the first point. They are saying incident ray, that is incoming ray, normal, that is perpendicular, which I had drawn to find out the angles, and the reflected ray, they lie in the same plane. Now what do you mean by they lie in the same plane? The meaning is that you must have heard about x-axis, y-axis from the graphs. So what they mean is, suppose let us say the incident ray is present on x-axis. For example, it is present on the x-axis. Then normal and reflected ray will also be present on the same axis. So basically, what is same, that is x-axis. So basically, what same plane means is that all this incident ray, normal and reflected ray, they lie in the same dimension. That is what they want to tell. So they lie in the same dimension. That is what they want to teach. So the first law is very simple for laws of reflection. Incident ray, normal and the reflected ray, they lie in the same plane. And angle of incidence equals to angle of reflection. That is our second law. Right? This is the one. Now after this, let us talk about plane mirrors. We have seen two laws now, that is reflection we have seen, that is bouncing back of the light in the same medium, and we have also seen what exactly is laws of reflection. So there are two laws of reflection. One says that incident ray, normal and reflected ray, they lie in the same plane, and another law says that angle of incidence is equal to angle of reflection. Now let us talk about plane mirrors. What exactly are the plane mirrors? Let us talk about this. So plane mirrors are nothing but your home mirrors. The mirrors which are available at your home are nothing but called as plane mirror, like this. The one which is shown in the diagram, that is the same thing which is available at your home, and those are called as plane mirrors. Now before we get into the properties of plane mirror, let us try to first understand what mirror is made up of. Okay, so obviously you can tell the front part of the mirror is made up of what? Glass. So basically it has three layers. Basically any kind of mirror has three layers, you have to understand. The first layer you are going to encounter is nothing but glass. The first layer you have is glass. Okay, so this is your first layer. Your first layer is glass. What is your second layer? Let us talk about the second layer. Second layer is of silver coating. Okay, second layer is for silver coating. Okay, so this is silver coating. And there is a third layer that is for paints. There is a third layer for paints also. There is a third layer for paints also. So basically there are three layers: glass, then we have silver coating, and then we have paints. Okay, but why so many layers? Like there must be some reason, no? Like why we have so many layers? Okay, let us try to understand that what is the function of glass, what is the function of silver coating, and what is the function of paints. Okay, so let us try to understand that. Okay, so glass we already know that is a transparent material, so obviously that is going to help us in our mirror, but we just want to know what is the function of silver coating and paints. Silver coating, it is actually a very highly polished material, and because of that the reflection is going to be happening with very high accuracy. So basically whenever the ray of light comes on this mirror and it is going to pass through that glass, it is going to be reflected by because of that silver coating. So silver coating is basically helping in what? Reflection. So helps in reflection. The reflection alone is happening because of silver coating. So you have to understand that silver coating is the most important part of the mirror, helps in reflection. And what is the use of paints? What is the use of paint which is applied beyond the silver coating? The paint is used for protection of whom? The silver coating. See, silver coating is just a coating of silver, right? So basically, it needs some kind of protection, because without protection, it will just wear off. So hence, what we do is we apply paint also at the back end side. So this is for protection of whom? Protection of silver coating. Okay, so this is quite important. You have to understand that silver coating is used for reflection, and that paint which we are talking about, that is exactly for the protection of silver coating itself. So basically, how many layers are there in the glass mirror? We have three basically layers. First layer is glass, second layer is silver coating, and third layer is paint. So that is how, so let's say, are the layers of mirror. Now let us talk about the properties of the plane mirror. These are our home mirrors basically, right? So many of these are, you already know about these points, but before we get into the next point, kindly subscribe to the channel. This channel is really important for you. We are going to bring a lot of quality content, and for that it should propagate, and hence I would urge you to please subscribe the channel so that maximum students can have the highest benefit possible from these kinds of sessions. So kindly do subscribe the channel and do share the channel and like this video. Thank you so much. Now let us talk about the next point, that is properties of plane mirror. Now in properties of plane mirror, the same size of the image and the object, that is the most important part you have to understand, that the image and the object, they will be of the same size. That is the most important part. Like for example, when you stand in front of your mirror, do you see that the image is, suppose let's say, larger or shorter than your face? Whatever the size of your face or the body is, the same size you will get in the mirror, right? So that is the first point you have to understand. The same kind of shape you are going to get. The size of the image, this is the image, the girl is looking, this is the object. So object means, so let's say the one which is present in front of the mirror, and the image is nothing but the reflection of the object. So you have to understand that the image is not going to have some kind of different shape. The same size of that object you will get in the mirror also. Okay, so that is the first point of the plane mirror property, that the same size of the image and there is the same size of the object. Now let us talk about the second point, very important property of the plane mirror. Distance of the image from the mirror is equal to distance of the object from the mirror. Now let us try to understand this. For example, if this is our mirror, okay, this is our mirror, and we are showing it with the help of, suppose let's say, these lines represent silver coating. That line, what is the meaning? Basically rigid coating or silver coating you can say. So that is the representation of the mirror itself. So what we'll do is, mirror can be shown in that way. You don't need to draw the complete mirror whenever you want to show. Suppose let's say this is not required in your so let's say in your class, but if you really want to represent a mirror on the page, you just draw a line and then you draw oblique lines behind it. You draw oblique lines behind it, and that would be your mirror itself. Okay, so for my so let's say proper representation, what I will do is I will draw a line and then I will draw oblique lines, but with some another color, so that you can understand the importance of it. What these lines represent? These lines represent silver coating. That means this is a mirror. This is a mirror basically. So just consider, for example, okay, that a person is standing in front of it. Take care. So let's say the person is standing here. Let us draw that person. So this is our person. He is standing here. Okay. Now you will be able to see the same kind of person in front. Okay. So you are going to get the same person in front. So the second property we want to understand is that the distance. This is the object. This is the object. This is the mirror. And this is the image. So they are saying distance of the image from the mirror. Okay, the distance of the image from the mirror is equal to the distance between the object and the mirror. For example, if the distance between the mirror and the image is, suppose let's say d2. Suppose the distance between the mirror and the image is d2, and the distance between the object and the mirror is d1. And this is plane mirror, for example. This is not normal mirror. Suppose let's say this is plane mirror. So according to this property, you have to understand that these distances will be equal. So d1 is equal to d2. d1 is equal to d2. You have to always remember that whenever an object is standing in front of a plane mirror, the distance between the object and the mirror is equal to the distance between the image and the mirror. So the distance will be same, and you can check it yourself also. You can just stand in front of the mirror, and suppose, let us say, if you take one step back, the image will also take one step back. If you take one step forward to the mirror, the image will also take one step forward to the mirror. So you can just check yourself that whether the distances are the same between the object and the image towards the mirror. You can check yourself, right? You just stand in front of the mirror, take one step back, and you can observe yourself that the image is also taking one step back. So that is the second property which you have seen. Let us talk about the third property. Image is vertical in position, that is upright. Now you must have seen that, suppose let's say if this is your object, you are going to see the same, suppose let's say object image, like the the head will be head and the toes will be toes. Like for example, I will just give you some certain example. Now there are certain mirrors. For example, in which if you stand in front of it, you are going to get the same image. Okay, this one. And suppose let's say there will be a certain mirrors which are going to give you upside down image. Like for example, this is the kind of image you might get. Like this is called as inverted image. So this is object, and this is your image, and in this case also this is image. And what is this white line? That is basically your mirror. So I can just draw the oblique line so that you can understand that it's a mirror. Okay, so these are oblique lines we am drawing. So that is basically called as mirror. So you have to understand one thing, that suppose let's say if your object is standing in front of the mirror and you are getting the same image, like that means head is head. I'm just going to give you some details about this figure. See, if this is the head and this is the head, and this is the, suppose let's say the bottom part, the toe, okay, the bottom part. Okay, so I will do one thing, I will use the same terminology. Instead of writing down the head, I will just write down the top. I think that will clear your image. So this is top, so this is top, and this is bottom, and this is bottom. This happens in what kind of mirror? Plane mirrors. This happens in plane mirrors. And suppose let's say your top is getting converted to bottom. You can see in this kind of mirror, the top is getting converted to bottom, and the bottom is converting to top. You can see. What kind of mirror this is called as? This is called as spherical mirror. This is not in your syllabus, but you can just remember that this is called as spherical mirror. So this is upside down image. So are there certain names for this? Yes, there is a certain name for this. You can call this particular image as called as erect image. This is called as erect image या फिर upright image. Erect image or upright image. Right? And this kind of image which is upside down, this is called as inverted image. This is called as inverted image. Now you just have to tell me what is available in the plane mirrors. If you see yourself in the mirror, do you see your head as it is or it is at the bottom? You see the head as it is, right? So that means our plane mirrors which are available at your home, those basically give us what kind of image? Erect image, that is upright image. We do not see our head at the bottom, right? Our top is at the top, so that means the kind of image we get at our home, that is plane mirrors, is erect image. So that is another property we have seen. Now let us talk about the next point. Image is virtual, that is cannot be taken on the screen. So let me just tell you in short that this is actually not in your syllabus, but definitely you can understand like what examples are there in the images. So there are two types of images. The images are of two types. One is called as virtual image and another one is called as real image. Virtual image and real image. Let me just give you quickly in a shorter way. I will just explain you what is the difference. See, virtual images, you cannot take these images on the screen, and real images can be taken on the screen. But question is, what is the meaning of the screen? You must have seen, so let's say movies, right? Theaters, you must have seen. So you already know that the image is projected on the cloth material or the fabric which is present in the front of the theater, right? So in the movie theaters or the multiplex, whatever the movies you see, the images are projected on the screen, right? Okay, so that is called as real image. That is exactly called as real image. So real image is something which we can take on certain screen. For example, if you keep, suppose let's say, a kind of mirror, and suppose let's say if you put, suppose let's say, a screen in front of it. Screen can be, what are the examples of screen? Screen can be anything. It can be a cloth, it can be a paper, it can be anything, it can be even in your hand also. You can, even your hand can act as a screen. So basically it is something on which you are going to observe object. So even your hand is also a screen. So screen is basically what, a substance or any material on which you are going to observe. You basically, you can just say it's a platform on which you are going to observe image, on which you are going to observe image. Are you understanding this? That what is the meaning of this thing? Like for example, what is the meaning of screen? Okay. So screens are very simple. Screens are nothing but on which we generally observe the image. So images are of two types, virtual or real. Some images can be taken on a cloth. For example, if you can just hold the cloth in front of that particular mirror or lens, you are able to capture that image on that particular cloth. But sometimes it is not possible. Now you just tell me what is your experience. For example, if you are in front of the mirror at your home, just consider that for a second, that you are in front of your mirror at the home, and you are able to see yourself. After that, somebody takes a cloth material near the mirror. Now you tell me whether it is possible that whatever the image you are seeing in the mirror, that same image you are able to take it on the cloth material. Is it possible? No. So hence that kind of image is called as virtual image. So it cannot be taken on the screen. Cannot be taken on screen. Are you understanding the point? Cannot be taken on screen. And real images can be taken on the screen. It can be taken on screen. So what is the example for this? Best example for virtual images? Your home mirrors, that is plane mirrors. So whatever the images that are created by plane mirrors, that is your home mirrors, are nothing but called as virtual images. Plane mirror is the best example. And what are real images? Where we can see real images? Theaters can be the best example, right? Multiplexes and theaters can be the best example wherein you are able to take the image on a screen, right? Suppose let's say the cloth fabric material which is present at the front, so that is basically the logic, right? So multiplexes can be the best example, multiplexes or theaters. So those basically show real images. Now let us talk about the next point, that is laterally inverted. Like what exactly is the meaning? So I just want to, suppose let's say, indulge you in one of the experiences you must have seen or must have observed with the mirror. Suppose let us say this is the mirror at your home, that is plane mirror, and this is the ground surface what you have. Okay, and now you are standing in front of the mirror. For example, this is you who is standing in front of the mirror. So this is you. Okay, you are able to see yourself in the mirror. You are able to see yourself in the mirror, right? Okay. And now after seeing, you just observe your hands. Okay, you just observe your hands. Okay. Now you do one thing. You do the same experiment at your home also. This is just a simple activity you can do. For example, now if you are observing the mirror, this is your plane mirror, and you are observing yourself in that mirror. So if you observe closely, if this is your right hand and this is your left hand, suppose let's say in reality, and if you see the image, you will be able to see that your right hand has converted to left hand. Your right hand has converted to left hand and your left hand has converted to right hand. Are you understanding this? That is what happens. Lateral inversion. That is what exactly happens. Even if you write down the letters, for example, if this is your mirror and if you have some 4 letters in front of it, like on this side, that is ABCD. The first letter that is going to appear is D, and that too laterally inverted. So that would be D, would be something like this. Then there would be C like this. Then there would be B like this. Okay, and then there will be A like this. Are you understanding this? So this is called as lateral inversion. That means right will become left and left will become right. So this is the position of so let's say the image which is observed in the plane mirrors. That image is laterally inverted. That is, left side of the object is seen to be the right hand side and vice versa. So this is exactly what happens when you see the image in the plane mirror. So you must have observed this. Just stand in front of the mirror and you will be able to see that your right hand has become left hand in the mirror and your left hand has become right hand in the mirror. So this is called as lateral inversion. So plane mirrors generally show what kind of inversion? The images are laterally inverted. Okay, so that you must have understood. So what is the meaning of lateral inversion? Yeah, for lateral inverted, it means left becomes right and right becomes left. Are you understanding this? Left becomes right and left becomes left. Okay. Now let us talk about regular and irregular reflection now. So we have gone through all the properties of the plane mirror. Now we are going to look into regular and irregular reflection, like what exactly is the meaning. Now in regular reflection, what happens is that there are 2 surfaces on which the rays of light can hit. For example, let us just take a surface which is very smooth. Okay, let us take a surface which is very, very smooth, like this kind of surface. And let us take another surface which is very, very rough, like this. Okay. So we have 2 surfaces. One surface is very smooth surface. And another surface what we have is a rough surface. This is a rough surface. Now for example, suppose some rays of light are incident on smooth surface. For example, this is the ray of light which is incoming. So these are parallel rays which are hitting this smooth surface. After reflection from a smooth surface, they will also go in the parallel direction again. Even though when they were coming towards the smooth surface, they were suppose let us say parallel to each other, and even after reflection, they will be parallel to each other. Are you understanding? This is called as regular reflection. Regular reflection is what? When all the rays of reflected rays from the surface, such as smooth surface, are parallel. Okay, so you can see all the light rays are parallel after reflection. So this kind of reflection is called as regular reflection. And what must be the irregular reflection? This is irregular reflection. In irregular reflection, whenever the incident ray, for example, they are coming parallelly to each other, but after reflection, they won't be parallel to each other. Right? That is the meaning of that. One might go in this direction, one might go in this direction, one might go in this direction. So after reflection, they are not parallel to each other, and that is called as irregular reflection. So when all the rays of light reflected from the surface, and this happens in what kind of surface? A rough surface. And if the reflected rays are not parallel to each other, that is called as irregular reflection. So you have to understand that regular reflection happens in what? It happens in smooth surface. And irregular reflection happens in what? Rough surface. And what are these? Suppose let's say after reflection, the rays will travel parallel to each other. So reflected rays are parallel. Reflected rays are parallel. And in this case, reflected rays are not parallel. That is what you need to remember. Reflected rays are not parallel. Not parallel. That is very important. So not parallel. And so you must have understood now that regular reflection happens in smooth surface and all the reflected rays are parallel to each other, and reverse thing happens with the irregular reflection, that the surface is rough and after reflection the rays do not go parallel to each other. But what about laws of reflection? Does regular reflection, out of the following two which we have drawn, who is a regular reflection? The first one is regular reflection. So let me just write down the name there. This is called as regular reflection. This is the so let me just write down the second one, that is this one. This is called as irregular reflection. This is irregular reflection. Okay. So you must have understood now which is regular reflection and which is irregular reflection. But what about the laws of reflection? Does regular reflection follow laws of reflection and does irregular reflection follows laws of reflection? Actually, both of them follow laws of reflection. This also follows laws of reflection, and even irregular reflection will follow laws of reflection. So I hope this point is clear that your regular reflection will also follow laws of reflection and irregular reflection will also follow laws of reflection. So can we have some basic examples for regular and irregular reflection, like what kind of surfaces we are looking for? The surfaces we are looking for regular reflection, these are highly polished surface. So any highly polished surface will act as the example for regular reflection. So it will exhibit regular reflection. So best example you have around you is mirror. So mirror is the most perfect example for exhibiting regular reflection. And what are the substances which can exhibit irregular reflection? Those are paper, wood, walls. So these are the example: paper, wood and walls. Those are rough surfaces. So basically those will be exhibiting what kind of reflection? Irregular reflection. These are the rough surfaces. Now let us talk about multiple reflections. Can we have multiple reflections? Like till now we were able to see just one reflection. So is there a possibility wherein we can have multiple reflections? So yes, there is a possibility. You can definitely go for multiple reflections. So how to get multiple reflections? So what you need to do is you need to arrange two mirrors in a different way. For example, suppose let's say this is your first mirror, right? And this is your second mirror which you have kept. This is your second mirror. So what you have to do is basically you have to arrange two mirrors in such a way that there should be a certain angle between the two. So you can vary the angle between the two mirrors. Suppose let's say if I am saying this angle is x degree. So you can change the angle between the two mirrors. This is mirror 1 and this is mirror 2. So you can change the angle between the mirror 1 and mirror 2, and depending on the angle change, you are going to get multiple reflections. Like multiple reflections means what? Multiple images. Number of images you will get, multiple images. But can we know without, suppose let's say the experiment, can we know like what kind of, how many images we are going to get? Yes, there is a formula for that. And what is the formula? The formula is number of images is equal to 360 degree divided by angle between the mirrors minus 1. For example, you have arranged the mirrors in this way. Okay, you have arranged the mirrors in this way. And the angle which you have used is 60 degree, for example, between the two. So you just have to remember that if you want to know what are the how many images will be formed, so you are going to use a simple formula. Number of images is equal to 360 divided by angle between the mirror. What is the angle between the mirror? That is 60 degree minus 1. So 0, 0 cancel, 6 1s are 6, 6 are 36, minus 1. So answer would be 5. Very simple, 0, 0 cancel, 6 1s are 6, 6 are 36, 6 minus 1 is 5. So how many images we are going to get in this case? We are going to get 5 images with 60 degree. Are you understanding? So it's a very standard formula that you are supposed to use. That number of images is equal to 360 divided by angle minus 1. So that is the formula which you are going to use. Okay, so very quite important formula. So kindly mark it in your textbook and kindly remember that. Number of images is equal to 360 divided by angle of between mirrors minus 1. Now let us talk about periscopes. So you must have observed, you must have seen in the movies that in the submarines we have lots of, for example, periscopes. Like this is called as periscope. So basically this is some kind of a way to see some object which you are not able to see normally. For example, in the water, we cannot just peep out outside our head and we can see, right? It's not possible that we can take our head outside the water and see what is available in the front. So generally, the submarines are fitted with periscopes. So this is called as periscope, right? Periscope, periscope. And the combinations of mirror are used to see the objects that are not in the direct line of sight. So what is the use of this periscope? Periscope is used to see objects which are not in the direct line of sight. What is the meaning of direct line of sight? That means which are not visible to us, we are able to see those with the help of periscopes. And what kind of angle should we keep between the periscope? That should be 45 degrees. So how it is constructed? So basically the construction is something like this. Suppose if this is the construction of your periscope. So you can just keep your mirror here. This is your first mirror, okay, and this is your second mirror. Okay. Now a person is observing from here. So suppose let's say this is your eye. Now some certain person is observing from this side. So you have to understand that the ray of light is going to come from this side. Okay. Whatever the object that particular that person wants to see, he just has to observe through the periscope. Then the rays of light will come from this end. It will hit that mirror. It will be reflected towards another mirror. And it will again reach towards the eye of that person. And then, as you know, if the rays of light are entering into our eyes, then we can see the object. So whatever the object is present here, like you know, that object you will be able to see. Fine. Okay. So what should be the angle between these two mirrors? There is a certain necessity. The angle should be 45 degrees. If you keep these mirrors at 45-degree angle between them, then definitely you will be able to see that object. So what is the use of periscope? To see objects which we are not able to see. And what is the degree? How much degree should we keep between the mirrors? 45 degrees. And what is the use? To see objects which we are not able to see. See objects which are not able to see or which are not in the line of sight. So that is today's session. So in today's session, we have learned lots of great deals of things. You can watch this video again and again to come to that topic and try to understand that, right? So kindly subscribe the channel, because this quality content is brought to you by lots of hard work, and hence it's so let's say necessary that you should also propagate it, you should subscribe it, you should share this video so that even your friends can get advantage of this. So kindly share the video, subscribe the channel, so that whatever the updates or new so let's say the lectures I produce, it should be able to reach you in time. So kindly subscribe to the channel, that's the most important part, and kindly like the video. So thank you so much for today. We'll be meeting in the next session, and I will let you know soon when it will be posted. The posting will obviously be noted to you once you subscribe the channel. So once you subscribe the channel, you will automatically get the notification. So stay tuned. Thank you so much for today. Bye-bye.